to the Fight Club.
Okay, we are going to be talking about ARKit and lighting today. Give me 1 second to get set up here. Okay. Okay, today we're going to start with a new project, and again the focus is on using lighting with ARKit and understanding, at least getting a taste for what it offers. And we're going to use our standard template. Clean it up a little bit. We just want to really just use the basics. Okay. And everything we're not going to use today, I'm going to be getting rid of. Okay. All right. Okay, so one thing I'm going to do is I'm going to enable the show feature points on our debugger. I'm trying something a little different today too. I'm going to try splitting the screen between. Yeah, actually, I can probably show all of that and then show reflector. Let's try that again. Trying to get reflector up so I can show off my screen here, but we're having some problems. Okay, sweet, there we go. So now you can follow along with my screen as we go here. So we're going to quickly just launch the ARKit template, because it's kind of stripped down just to make sure everything's working. And it is, and now we should see our feature points. All those little yellow dots you see are feature points that ARKit detects for us that we can use as anchors. Okay, cool. So the first thing we're going to do today is we are going to add a simple tap gesture recognizer to our scene view. So just a basic tap gesture recognizer that when the screen is tapped, it's going to call the handle tap method. So we'll create that. Create that right here, just so we can see it. Tap. And it takes a gesture recognizer. So gesture recognizer. Okay, cool. So when our scene gets tapped, we're going to get called back here. We're going to be able to get the position of where the user tapped by using the recognizer. So, and we're going to translate that based on the position in the scene view. So we're going to say let position point equal recognizer location in view, and the view is our scene view. Okay, and now we're going to do a hit test, and we're going to try to find a feature point that corresponds to this position point right here. I don't like the word position point. Let's say touch point. So then we're going to say guard let hit result equal scene view dot hit test, and we're going to hit test for types right here. Yep. We're going to pass in our touch point. We're going to say give me all of the results from the scene view that correspond to this point, and it acts as an array. So it's an array that goes through in 3D space at this point, and it finds and it returns all of the result types from your scene. So we're going to look for feature points, and we're just going to grab the first one, which is in our case the closest one. And since we're guarding, in case this does return nil, we're just going to return. All right. A little more space here. Yeah. Okay. Now, now we're going to create, at the point where you just touched, we're going to create a cube. So we're going to say cube. Some of this is a review from some earlier talks that we've done. Cube node equal SCN node. And it's going to ask for some geometry. And for that geometry, we're just going to use a SceneKit box. So SCN box. And we'll just give it, and this is in meters, so we want to make it kind of small. 0.1, 0.1, 0.1, and 0. So we got our node. And for now, let's just give it a material, like a simple material. We'll get back to materials later. Material.diffuse.contents, and we'll just give it a red color for now. Okay, and then our cube node dot geometry dot materials. It's looking for an array, so we're going to pass in just that simple material. You know what? For now, let's not even bother with the material, because it's going to give us a white material by default, and actually that shows off what we want to do pretty well. So sorry about that. We'll skip the material. And then we're going to set the position of where our cube should be. So cube node.position. And then we're going to take the hit result. So we're going to take that feature point, and we're going to use that feature point to set up where our cube's going to be. So we create a SceneKit vector, 3D vector, and we take our hit results world transform property, and essentially the X component of it, the Y component of it, and we're going to raise it up a little bit. So it's up off of the ground a little bit. Actually, we're not basing this on a plane, so we can actually just put it at the exact same location. And then, so X, Y, and Z will be identical to the touch point that we found using this hit result. And then we just have to add the node to our root node. So our scene view is a scene which has a root node, and we're going to add a child node to it, and that'll be our cube node. All right, this should work. Again, this is mostly review here, but it's good to review. Oh, come on, reflector, where'd you go? Sorry guys, reflector is screwing up on me again. There we go. Okay, so let's get back to it. We're going to detect a feature point where I tap the screen, and we'll be able to get a hint because remember we're showing that debugging information with all those little orange dots. Look for a dot. Okay, there we go. So right where I tapped it, we got a cube, and we can add another cube over by our buddy FDR. It's kind of farther away. You can add one under the desk where it's a little darker. And it looks a little weird. I guess this is where we're going to get started thinking about these things, is that you have a dark environment with my trash can under my desk, but a bright glowing white cube, which looks out of place. And for a demo, obviously, whatever. But if this were a real thing, like a real 3D object, it would look pretty weird with that screwed up lighting. All right, so let's... Okay, so there's a couple things we can do next. The first thing we can do is we can use something on the scene view. So we can say scene view dot auto enables default lighting, and that's a Boolean value that determines whether the scene adds lights to a scene. So I'll show you what that means. And I'm pretty sure it's off by default. Let's just double check. Default is no. Yep. So we're going to set it to true, and I'll show you what that does. All right. Let's take a look at this cube and see how it's different. You see, so what it essentially does, what enabling this does, basically adds like a flashlight right where my phone is, pointing out towards the virtual object. So you can see that my phone is right in line with the cube right there, so it's lighting it up pretty well. But the top is just getting a little bit of light. It's still in the shadows, but as I raise my phone up over the cube, the light starts to shine more and more on the top until I get to the top, when it's well lit, or pretty well lit anyways, and the side gets more of a shadow. You can kind of see that over here too. So that adds some basic, like real world-ish lighting, especially if you're interested in this kind of an effect where you're really like focusing a spotlight or a flashlight directly shooting out of your phone, right? So that's what that thing does. We can look at it down here too. So Okay, so that's what enables default lighting does. We're going to turn that off. We're going to look at some more options as well. We are also going to look at adding a scene kit light, like a specially created scene kit light that's created by us. So add another helper function. And we'll call that private func. Insert spotlight. Okay, so we're going to create a scene kit. So here's what we're going to do. We're going to create a scene kit light. There's lots of different types of lights you can create. And we're going to configure it. Then we're going to create a scene kit node. And we're going to set the light as our node's light. And then we're going to add that node that we created to the scene kit scenes root node. And just like we have a box sitting out there in real world space, we're going to have a new node, which is the light, which is sitting out there in real world space, which can interact with our virtual objects. So it can shine like an ambient light over everything, like a nice warm glow. You can have a harsh spotlight that shines on things. You can set the angle of things. You can rotate the angle of the lights. But let's just get started with a real simple example. So let's create a spotlight. CM light. Then we'll set its type. Spot. Again, I'm not an expert in the scene kit stuff, so some of it I've just read from some basic tutorials that I've been catching on the web and on some Udemy stuff. So I can't really explain all the details to you guys, but I can walk you through what I've learned so far. So there's an inner and an outer angle. We're just going to set them at 45 for now. Inner angle. So the angle in degrees of the area fully lit by a spotlight equals 45 spot outer. The angle in degrees of the area partially lit by a spotlight. Okay, so there's our basic configuration of a scene kit light, which doesn't do anything yet. We have to add it to a node first. So let spotlight node equal a scn node, just like a normal node, and spotlight node. For now, we're going to give it a light. So it takes as a parameter, every node can have a light, optional light thing here. So we're going to give it our spotlight. Then we're going to position it. Node position. So again, we're going to use our SCN vector 3. SCN vector 3. We're going to set it. The X and the Z are going to be 0, but we're going to set it above us 1 meter. So we're going to put it up 1 meter by doing this. And then we're going to, so imagine we have a spotlight and we have a pulley and we're just pulling it straight up in the air by 1 meter. And then it's got a rig so you can change the angle at which you're shooting the light. And that's called, in scene kit world, that's called the Euler angle. So we're going to set the Euler angle. The node's orientation expressed as pitched, yaw, and roll, each in radians. Okay. Close SCN vector 3 make. And this thing starts off shooting, I think, straight out. So we're going to rotate it. We're going to rotate it by negative float negative pi divided by 2, 0, and 0. Actually, we'll do a little small one here, and we'll see why in a second. Okay, so we've set our spotlights, our spotlight node's type of light, its position in our virtual world here, and then the angle at which it's shooting down. Now we just have to add this node. So we have our scene view, scenes, root node. Again, we're just going to add a child node like we always do. So spotlight node, and we just have to call this. So we'll call this once when view did load. Insert spotlight. Okay, sweet. All right, so now we're telling SceneKit, okay, we are taking care of, we are in charge of the lighting here, right? So let's fire this thing up. Okay. So you can see the box is totally black, but it's all lit on top. And that's because we have a spotlight above us. And we create another box over here, and only part of it's lit. And that's because we have the spotlight shooting down at an angle like this, and it determines, SceneKit determines for you, and I guess ARKit as well, exactly what in our virtual world here is lit up. So let's, if we put one down here on the floor, barely anything, and over here in the corner, it's not going to get hit by the light at all because the light is up here shooting down at an angle like this. Now, we can change the angle that the light is allowed to come out. We can change the Euler angles, and we can change the position. So those are all animatable properties that we can work with. But that's basically what a spotlight looks like. It's not an ambient light. It is not the kind of like intelligent lighting that will. It's not like an intelligent light that's necessarily going to like render everything perfectly like it should be. But if you're looking for like a spotlight effect, then this is going to work great for you. All right, moving on. There's more we can do. Now, there's another thing which I was learning about today, which I found really interesting. PBR. No, not that kind of PBR. Okay, so let me call it up here. Okay, so physically based rendering. So, which came out last year with iOS 10. I guess SceneKit has the ability to have certain materials, and it takes account of things like how metallic something is, and how shiny things are, and how it refracts and reflects light. So if you can you basically set these different types of materials, and you tell SceneKit that we're going to be doing physically based rendering, and it will take care of exactly what your object should look like at those different places. Let me see. Show you guys some information. Yeah, I've been using this guy's stuff. It's pretty good. That's not what I want. Okay. So, physically based rendering. So this is probably the coolest thing that I've seen so far. Physically based rendering. So you can see some examples, like incredible looking examples that in different light conditions, these are 3D generated objects. They look appropriate at those different conditions. So let's see. So basically you set materials for all these different types of material, and then SceneKit will figure out how to render them for you. And he had a link to a place with good examples on where to get these things. Ah, yeah, freepbr.com. So I went ahead, I went to freepbr.com. I thought sandstone was pretty sweet, so that's what I grabbed. We can do that. Well, just do it together. And it gives you all the textures you need. So let's check it out. So freepbr.com, download a texture. I'm gonna, and all the textures are really is just essentially just PNGs for the most part, right? So there's a preview which we don't need. I'm gonna dump that, and the rest of these things I'm just gonna drag into my asset catalog, and you'll see why. Okay. Oops, sorry. Try to go to my view controller. Okay, so we have our different textures. Now, when we go and we want to create our cube, we're going to create a material to go with it. Okay, let's give ourselves some space here. So, material equal SCN material. And then we're going to tell our material that its lighting model is going to be physically based. Okay? And now all we have to do is set the different contents of this thing, of this material, to be the things that corresponded to the thing we just, those images we just downloaded. So we'll just go through this one by one. Diffuse contents equals, what is this one called? Sorry, 1 second here. Okay, let's start with albedo. Why is it albedo? Oh, man. Okay, we're going to go with albedo for the contents one. Sandstone cliff dash albedo. Material dot roughness dot contents is going to be equal to sandstone roughness material dot metalness, so it's like the metalness of the contents equals metal, and finally material dot normal, an object that defines the normal orientation of the surface at each point for use in lighting. Contents equals, oh, what did we use for this one? Okay, sand normal. Okay. All right, so we've set a bunch of different images here. I think this is all of them that we have to do. Let's go back to the tutorial at least. Take a look. Diffuse, we used albedo. Yep. Roughness, metalness, and normal. Okay, that's the one that worked in the tutorial, and it worked for me earlier. Let's see if there's anything else we have to do. But now, okay, yeah, we have to set our node. That's what we didn't do earlier. We have to set our node geometry materials equals this material. Let's take a look. Now, there's other things you can do to help improve the way this renders, but this already is a pretty good start. So my office is relatively well lit. We'll add a couple different types of conditions here. So we'll add a point here. And that looks like sandstone. That actually looks pretty awesome. Now let's pick one under my desk versus the one up here. So this is definitely brighter up here. Let's look at one over here. Now in the really strong light conditions, it looks different, right? So again, I'm not an expert on this one, but depending on your lighting conditions, you're going to get different effects here. This is definitely something I want to dig more into as we go. I mean, not today, but you get a sense that at least that doesn't look like it's glaringly bright. It kind of fits in under the desk a little bit better. Now let's see if I shut my light off. Let's see if I shut my office light off. Wait. Did that change? I don't know. Okay. Well, that's how that thing works anyways. There's one more thing we're going to take a look at. Let's actually stop with the material. So I'm going to comment out some of this material stuff. And we're going to actually comment. Actually, we'll keep the spotlight. So we're going to go back to the spotlight. Oh, the spotlight. Hold on a second. I wonder if that was impacting. Let's get rid of the spotlight real quick and go back to our materials. Yeah, the material was under the artificial spotlight before, which was, I think, screwing things up. So let's go back to under the desk. Yeah, look at that. That is like full on, looks like it's dark. And then we'll put one over here in the light. Here, let's turn the light back on here. And that looks like it's really well lit. Go back onto the desk. It's super dark. Okay, that's what was going on. The spotlight was screwing things up. Oh, that is awesome. It's nice and glowy and kind of bright, like as if it's under my light. And then back to the dark one, and it's super dark, and you can barely see it. Oh, that's awesome. Okay, cool. Okay, now we're gonna turn the material back off again. And what we're going to do now is we're going to do some light estimation on our own. Say we don't have access to these physically based rendering. We're going to change it up. So we're going to use a delegate method which is renderer update at time. Okay, so this gets called pretty much, this gets called all the time. All right, this gets called, I think, I don't know under what conditions this gets called, but I know it gets called very, very frequently. Let's see if we can find out. All right, well, we'll see in a minute. So basically what we want to do here is we want to get our session's current frames light estimate. So as we know, as we went over last time, our scene view has a session, okay, and the session has a current frame. So basically, what the world looks like to ARKit, and that part of what you can get from that current frame is an estimate of the lighting, like how good the lighting is. Is it super bright? Is it overexposed? Is it perfect? Is it underexposed? Is it completely dark? So here's how we're going to do that. We're going to say, when this delegate method gets called, scene view dot session dot current frame dot light estimate, and then we're going to, okay, now let's just do that first. Else return. Then for now, let's just print light estimate dot ambient intensity. Okay, so let's check this out. All right, so you can see it's firing really pretty frequently over here. Let's put it right under my light, and it's kind of freaking out. It's at like 1700, 1000 is like more or less perfectly exposed. You can, right at my light is like 3500, so that's crazy overexposed. Now let's go under my desk, and we're in the 70s and 80s, so it's super dark. Come on out, buddy. Sorry, you guys couldn't see that. So again, coming in, zooming in on the light, we're in the 4000s. Oh, I see what it's doing. A normal exposure, like just in my room, is like 950. Then under the desk is like 100 or 80. Okay. So what we want to do, and this kind of screwed me up at first. My first instinct was like, oh, well, what we can do is we can, if it's getting dark, we can turn up the spotlight. But really, all we want to do is blend in with our light intensity, right? So our goal here is to basically turn down our spotlight or turn up our spotlight as necessary in order to get our object, somewhat appropriately lit based on that spotlight. So let's give that a try. And so the first thing we have to do is we have to set an identifier on our spotlight. So we're going to do that up here, spotlight node. Name, so we just give it a string to identify it, equals spot node. Then we're going to come down here, and we're going to try to get a reference to our spot node. Yeah, let spot node equal our scene view dot scene. And then there's a method called root node. So then there's a method called child node with name. And we're going to look for spot node. And recursively true. So it's an optional property, so if we don't get it for some reason, we're just going to bail. And then all we're going to do now is we're going to set our spot node's light's intensity to the light estimate's intensity. Spot node light intensity equals our light estimate's ambient intensity. So basically, if it's a super bright scene, we want the object to be lit with a bright light. If it's pretty dark, we want it to be pretty dark. And so this is this is pretty rough, but let's give it a shot. Oh, wait a minute, let's see. Why don't we use default? Oh, wait, didn't have our spotlight turned on. Let's run that again. Okay, so we're gonna get some feature points. Okay, so you can see our spotlight is working. Let's put one over here, so we know that that doesn't hit. That one partially hits. And then if we shine some light on this scenario, I guess it would get a little brighter. And then if we, here, I can close my curtains and see if we can make it a little darker. Okay guys, sorry about that. Okay, so now it's as dark as I can make it, and let's see if we can find our, yeah, it looks like the spotlight turned down a little. I'll turn the light back on. Yeah, and the spotlight got brighter. Off and on. Okay, so you can see how that helps blend in our lighting model a little bit. Very cool. Okay, so there's definitely lots to learn. I mean, I know that I have lots I'd like to continue to practice here. Things like really getting a handle on this physically based reality. There's supposedly a really good WWDC 2016 talk about SceneKit and this topic that's worth watching. I know I'd like to get a little better understanding of these spotlight angles and also Euler angles. Like I can picture it in my head, but I don't have a good sense of how to really change things up in code. So that's some stuff I'm going to be practicing. Okay, thanks a lot, and any questions or suggestions, please let me know.